Okay, so this target is solving a quadratic system of equations. Ooh, I don't see my pen. Just a second here. Let me find my pen. Here we go. A system of quadratic equations. Oh, I need the light. There, a system of quadratic equations. So that means it's going to have one or maybe even two quadratics in the system together. Writing one variable in terms of the other to solve a system, that's substitution. And then the other method is going to be solved by graphing. To solve a system by graphing, you have to look for where the things intersect. And the intersection points are the places where they both have the same values. So that will be the solution. So we're going to look at the two methods now, okay? This is going to be a little bit hard to read, but I'll zoom it in. Okay, hold on.
No, I talking about grandma.
Oh, okay.
Nini. Can you come up to me down? Can you slow it down?
Okay, so can you hear me, Connor?
Yeah.
Okay, so here on the left is the substitution method, and I know you can't read all of the words because they're kind of tiny, so I'll read them to you. What is the solution of this system of equations? So they'll have this curly bracket to show you that it's a system where two equations are together. And then one of them will be linear. So this one down at the bottom, see how that says y equals x plus 3?
Yeah.
That will be the one that you'll want to use as your substitute. So that x plus 3 chunk, that can be a replacement for y, since y is equal to it. So I can put that in place of this y here.
Yeah.
And then that would give me x plus 3 equals all of the rest. And then I can work the problem. So that's what they did in all of the part here, okay? So we're going to do an example like that in a minute. The other way of solving is by graphing. When you solve by graphing, this part here is just showing you, you can go on a calculator or a computer with a Desmos, and you can put the two separate equations in there, and then you can look for where they intersect and get the coordinates for the intersection. And the intersection is the solution. Okay.
Yeah.
All right, so let's go ahead and do one. This one says to solve it by substitution. So if I were going to solve by substitution, then that would mean I would take this chunk that y is equal to and use it to replace the y in the other equation.
Yeah, I remember that.
Good. So you would have 3x minus 2 equals x squared plus 5x. Just kidding. That's supposed to be a minus sign. Minus 2.
Yeah.
And then we would need to get everything on the same side of the equation to solve it. So if I bring both of these over, I'm going to have to change their signs when I bring them over. So this is negative. Yep. Add this and subtract that. So that gives me 0 equals x squared plus 2x. And then that's plus 0, right? Good. So now I can factor this quadratic. Because you remember that factoring is one of the ways to solve. So I'm just looking at this and I'm noticing I could factor it. I can divide x out of it and I'll get x plus 2. Because x times x is x squared. and x times 2 is 2x.
Yeah.
And since that product equals 0, now I'm going to do that zero product rule, and I'm going to say x equals 0 and x plus 2 equals 0, like what we did last night. And then, yep. So those are our two solutions, x equals 0 and x equals -2. Okay. All right. Let's look at this for a moment. We're going to talk about solving by graphing a little bit more. When you solve by graphing, if one of your functions is a quadratic, it's going to have that kind of, it's almost shaped like a wishbone, right? Have you ever seen a wishbone from a turkey? No?
No.
Well, it's sort of like a horseshoe shape, but anyway, it's this shape. So you see, this is the curve. So that's the quadratic function, the curved one.
Yeah.
And then this straight one, that straight one is the linear function. So that has two intersection points. So it would have two solutions.
Yeah.
This one has one intersection point right there. So one solution. And then this one has no intersections. So it has no solution.
No.
Okay.
Yeah.
Now we're going. You do remember doing this before?
No.
I know. Okay. So now we're going to do this with Desmos. Okay. So I'm going to do, oops, not this problem. This problem right here in Desmos. So you can see my two equations are y equals -x squared plus 3x plus 2 and y equals 3x plus 2. So I'm going to get a window opened. Oops, it kind of got blurry. I'm going to open a new tab and I'm going to take you to Desmos. So that's going to take me just a second.
Yeah. Is that on my Google platform?
Desmos? Yeah, I posted. You asked me to put it in Google Classroom, so I put it in there one day. Okay, let me see. I'm going to share the tab with you now. Let's see. Share tab. Desmos. Share. Okay, so you should be looking at Desmos. Are you seeing it on your screen now?
Yeah.
Okay, good. So I'm going to type the equations for you. These are the two equations that were in our problem. Y equals -x squared plus 3x plus 2. That was one of them. Oops, I'm hitting equals. So 3x plus 2. Okay. So there's your parabola. The other equation is a line. The other equation is y equals 3x plus 2. So there's our line. So you notice that Desmos, let me zoom it in a little bit. Can you see all that?
Yeah.
They'll put a point right there for us. When it was zoomed out, they had a point on it, but when I zoomed it in, it disappeared. So you can see the intersection point is right there.
Yeah.
So that point is happening at 0, 2. So the coordinates of that point are the solution.
Yeah.
Now we have to put that on our graph, and we have to pay attention. When we put it on the graph, we have to make it look as much like this as we can. So we have to pay attention to how this looks along the x-axis here, what the x-intercepts are, what the y-intercept is, how the lines are intersecting. So now I'm going to take you back to my paper, and we're going to try and sketch that. So can you remember kind of how it looks? This is happening at -0.6. And then this one is close. Oops, this other one is close to that. And then this point here is at 3.5. And this one is at 2. And the vertex is at 1.5, comma 4.25. Okay, so what I'm going to do is I'm going to write kind of on the side of my paper. I'm going to write. Can I make my what?
Yeah. You get the demo
Get the Desmos off? Are you saying get the Desmos off?
Yeah.
Okay, I'm just writing the points on my paper before I take Desmos away because I need to know what they are before I lose the paper. Just hold on a second. Okay. So now do that. Okay. So I wrote down all the things that I was getting from the picture on Desmos. I wrote them on the paper, and now I'm going to put them onto the graph on the paper. Okay. So the first thing is, you see how I have a V there? That means that was the vertex. So the vertex was at 1.5, comma 4.25. I'm going to let every little square on here be a half. So this is 1, this is 2. This is -1. This is 1, this is 2, 3, 4. Okay, so since my vertex is 1.5, comma 4.25, that would be right here. That's my vertex. And then, so I took care of this. It says they were intersecting at 0, 2. So that's where the curve and the line were intersecting, which means that that's the solution. 0, 2 is the solution. I have here that I had an x-intercept of -0.6 for one of the things. So that's about right here. And the other one was here. And then 3.5. 3.5. And then here. Okay. So the parabola went like this and like that.
Yeah.
And then the line was, oops, like this. And then the line was like that. So that's how the graph looked. And the solution is the point where they intersected.
Yeah.
And the coordinates there are 0, 2. So the solution is 0, 2.
Yeah.
Okay. So that's really all there is to it. You either do substitution and solve the quadratic equation that you get from doing the substitution, or you make a graph in Desmos and you find where it's intersecting. And sometimes it will have one intersection. It could have 2 intersections. It could have no intersection. It just depends. So what I thought I would do for a little bit of extra practice is, well, maybe not exactly extra practice, but I want you to see that we can solve this exact same problem with substitution and get the same answer we had here. So I'm going to grab a spare piece of paper and work the same problem we just did using substitution. All right, here we go. So this was the problem. -x squared plus 3x plus 2 was the first equation. And the second equation was y equals 3x plus 2. So I'm going to let the 3x plus 2 be my replacement for the y in the other equation. Let me zoom that out. That's zoomed in too much. And so then I would put 3x plus 2 right there. And I would write 3x plus 2 equals negative x squared plus 3x plus 2.
My,
Interesting. Yeah. Minus that, minus that. But look what's going to happen. You can see what's about to happen, can't you? That's all going to. So you're going to have 0 equals negative x squared, right? Okay. So then to solve this, you would have to divide off the negative 1, which is still 0. And what is the opposite of squaring something? Nice job, Connor. So square root of 0 is still 0. So you get x equals 0. So that's x coordinate of 0. Now, do you know how you would get the y coordinate? Good. You would plug it into that. So you would go y equals 3x plus 2. Y equals 3 times 0 for x plus 2. So that would be 0 plus 2, which is 2. So y equals 2. So the answer would be 0, comma 2. And what did we get on our graph? We got 0, 2 on our graph.
Yeah.
Okay, so that is how you do. So it's not that tough, is it? It's actually kind of easy. So let's do, what do you think? Just do 2 more of those and that would be good?
Yeah.
That way we can finish by 7 o'clock. All right, so let's do, we will do both of them both ways. So we'll do them with the graphing and with the substitution and make sure that we get the answer the same on both. So let's do this one right here. We're going to have, oh, we can't do this one because this was our example. All right, so here, let me write that on here so I don't make that mistake tomorrow. Okay, so we want to do this one then. So I'm going to zoom that back in. All right. So 2x minus 8 is going to replace y. That will be 2x minus 8 equals
Why?
What about tomorrow?
Why you put that there?
Are you talking about that?
Yeah.
Oh, because I teach this lesson to the students tomorrow, and the paper that I did with you for the notes has this problem that's the example matches the problem in the practice. So I made a note so I can remember to change it so they don't have the same problem twice.
I will be one day.
Kind of, sort of, not exactly, but kind of. Okay, so now what do you want me to do? Good. What else? Good. So then that zeroes out, and I have 0 equals negative x squared minus x plus 20. So I have to factor this. So I have to think, what gives me 20 and a negative 1, right? So I'm going to go over here and make a list. 20 could be 1 times 20, but 1 plus 20 is not 1. So that one's not it. Next, I can do 2 times 10, but 2 plus 10 is not 1. So it's not that. So then I could try 4. 4 times 5 is 20, and 4 plus 5 is 9. That's really what it is. Oh my goodness. I just realized I messed up. This is a negative 1 times 20. So this should have been negative 20 right here. Oops. Okay. So this should be minusing. Do you know what I'm saying? I was doing it wrong because this was supposed to be negative 20. Okay, so now what I should do is positive 4 and negative 5. So x plus 4 and x minus 5.
Yeah.
I might have the signs backwards. I know what caused all of this to happen. I just realized. Because the x squared was negative. So maybe what I should have done, and I'm sorry I didn't think of it before, but if I divide negative 1 out of it, it makes it a positive x squared, and that makes it a better problem. And that's what I should have done. I'm so sorry. So that makes this x plus 5 times x minus 4. Okay. And the reason it has to be plus 5 and minus 4 is because this is a positive 1, not a negative 1. So over here, this needed to be 4 plus negative, oh, just kidding. Negative 4 plus 5 to go 5 minus 4, which is positive 1.
Yeah.
Yeah. Okay. So now we have x plus 5 times x minus 4 equals 0. So that means x plus 5 equals 0 and x minus 4 equals 0.
Minus.
Good. So when I go minus, I have x equals negative 5.
Oh.
Yep, you're right. So those are my two solutions. So that means that this problem has 2 answers instead of just 1. If it has 2 x's, you know what that means if it has 2 x's? It means it's one of these where it intersects in 2 places. So we have to get the y's that go with those x's. So now I'm going to just draw this down lower. The y equals equation for this problem is y equals 2 minus. You okay, Connor?
Yeah.
Okay. So where I got this from is back at the beginning of the problem up there. Okay. And I'm just going to plug in both of these x's to get the y that goes with each one of them. So now I have to go 2 times negative 5 minus 8, which is negative 10 minus 8, which is negative 18. So when x is negative 5, y is negative 18. So that means that is an intersection point at negative 5.
Yeah.
Now let's do it with the 4. So now we have 2 times 4 minus 8.
Hey.
Good. So 8 minus 8 is 0. So that means this one's happening at 4 comma 0. So if we graph it, we should get an answer at negative 5, negative 18, and 4, 0. So now I'm going to go put on Desmos, and we're going to check it on Desmos, okay? So let me present my screen, and I'll get Desmos. And I have to type the new equations. So the equations for this one were, let me see, I have to change these. 1 plus 12. And then the other one has to say 2x minus 8. Okay, so those are the two equations. Let me zoom this back out. So, yep, there's 2 intersection points, right? So I'm going to zoom a little bit. Okay, see this one here?
Yeah.
Look at those coordinates. Negative 5, negative 18. Does that sound familiar?
Yeah.
Yeah. And now let's go look at the other one. 4, 0. Yep, those are the ones we just had, right?
Yeah.
Yep. Okay. So that's how it goes. Do you feel like you understand?
Yeah.
Good. Okay. I'm going to go ahead and press stop on your recording. That's all we had to learn.